The COVID pandemic has underscored the need to more effectively expand affordable, high-performance broadband in our underserved communities, or as President Biden might put it, to build broadband better. In this presentation, we discuss one approach to doing this by deploying what are often referred to as open access fiber networks. To set the stage for that discussion, we'll spend a few minutes reviewing the history of what many of us have come to recognize as building broadband badly. A key point early in this history was passage of the 1996 Telecommunications Act, which occurred as the commercial internet was beginning to explode beyond its academic roots following the launch of the first web browser. The goal of the act was to usher in an era of increased competition, investment, and innovation, which would lead to lower prices and better service. To do this, the act set in motion a process of deregulation in the telecommunications industry. Unfortunately, while the deregulation moved forward quickly, its hoped-for benefits fell well short of expectations, as many of us still experience today. The basic economics of building networks, combined with lawsuits and lobbying, led to a situation in which the only real competitors left standing were telephone and cable companies. Making things even worse was the fact that in many areas, either the telephone or cable company operated as an unregulated broadband monopoly, something economists and common sense tell us is a bad thing. For example, since the financial returns of extending their networks much beyond city limits were often insufficient to attract cable operators, telcos often enjoyed broadband monopolies in these more rural areas. And as unregulated monopolists, they, in turn, had no financial incentive to upgrade their copper networks to much faster and more reliable fiber optic technology. Because DSL was increasingly unable to match cable's broadband speeds, cable operators came to enjoy near monopoly market power in the areas they did serve, which led to high prices and often poor service. As unmet demand for broadband continued to increase in rural communities, wireless internet service providers, known as WISPs, began to fill in some of these gaps, but their coverage, speeds, and reliability remained limited, and their prices were often high. And since many of them had limited access to capital, their ability to invest in network expansion and upgrades was also limited. Making matters worse, the federal government wasted billions of dollars by subsidizing networks that were already or would soon be obsolete, a practice that continues to this day. Over time, fiber networks deployed by municipalities and electric cooperatives began to emerge in some areas, pointing the way to a public infrastructure approach to delivering high-performance broadband. But in many states, including Michigan, laws were passed to restrict or even prohibit municipalities from making these investments. The result, which we see today, is a patchwork of unserved and poorly served areas in smaller communities, and broadband prices that are among the highest in the developed world. As we've painfully seen during the COVID pandemic, this situation urgently needs fixing. What we need to fix this situation is a strategy that provides every one of us the level of connectivity needed to participate, prosper, and contribute as a member of society, not only today as we move through the COVID pandemic, but also in a future that will rely even more intensively on fast, secure, and reliable digital connectivity. That connectivity must reliably provide the level of performance needed to expand and improve telehealth, online learning, and telework services, including speed, security, privacy, and ease of use. It must also encourage socially valuable innovation and be readily upgraded to meet future requirements. And importantly, these capabilities must be affordable for everyone, as reflected in the universal service goal set in the 1934 Communication Act as a cornerstone of the nation's communication policy. That goal was to make available to all the people of the US a rapid, efficient communication service with adequate facilities at reasonable charges. To achieve this goal as we enter a new phase of the digital age will require a different strategy than the one that's been pursued but has failed to deliver during the 25 years since the 1996 Telecom Act became law. The good news is that we now have an opportunity to update our national, state, and local broadband strategies thanks to a major expansion of federal funding, This includes the recently passed American Rescue Plan Act, which provides $220 billion to states and $130 billion to localities, and allows these funds to be used to make necessary investments in water, sewer, or broadband infrastructure. In addition, the Act provides $10 billion to states to support capital projects. It also includes a mix of broadband-related funding channeled through federal agencies, including the Federal Communication Commission, the National Telecommunications and Information Administration, the Economic Development Administration, and the Department of Agriculture's Rural Utilities Service. As of early August, an infrastructure bill including $65 billion for broadband was being considered by Congress amidst intense lobbying by incumbent ISPs, hoping to avoid competition from high-performance community fiber networks. As we consider how best to invest this dramatic expansion of federal funding, we stand at a crossroads. If we travel down one path, we will continue building broadband badly by funding networks that are, or will soon be, obsolete and that continue to generate monopoly profits for incumbent ISPs. The result, as we've seen for the past 25 years, will be a lack of competition, high prices, poor customer service, and poor and unreliable network performance. And importantly, it will leave us with networks that are expensive to upgrade, constraining our ability to benefit from digital technology and compete in the global economy. The good news is that we have the option to build broadband better by deploying open fiber optic networks that provide fast, reliable, and symmetrical speeds and are less costly to maintain and upgrade. This path also leads to healthy competition, lower prices, and better service by focusing on community benefits rather than increasing ISP profits and market power. These benefits include high quality access to telehealth and distance learning, and the ability to work productively from home and remotely and securely access banking, governmental, and other key services. To get a sense of why fiber is considered the gold standard in broadband networks and the only technology that qualifies as long-term infrastructure, let's consider two related factors: network capacity and future growth and demand for that capacity. This graphic compares the current maximum download speeds of different network technologies, including DSL, cable, 5G, and Starlink, the new generation of satellites currently in beta test mode. As the diagram makes dramatically clear, fiber's capacity is vastly greater than the capacity of all these other network technologies combined. And when its ability to support cost-effective upgrades is considered, fiber's effective capacity is virtually unlimited. Capacity is not fiber's only advantage. It also is the gold standard when it comes to network reliability, low maintenance costs, and ease of upgrading. If we want to be ready for whatever the future may bring, why would we deploy anything but fiber, especially when an increase in federal funding can help support a long-term investment in future-ready communication infrastructure? With bandwidth consumption increasing at roughly 40% per year, fiber's capacity and other advantages will be even more important in the future as demand explodes across multiple sectors of society, including those displayed on this slide. If our goal is to provide affordable, high-performance connectivity that supports healthy communities, healthy markets, and economic growth, we need to make a break from the policy approach reflected in the 1996 Telecom Act. As the past 25 years have clearly shown, that approach, which relied heavily on unregulated private network operators, particularly large telephone and cable companies and their legacy copper-based networks, was not up to the job. The good news is that a new and better model is emerging, thanks in part to technical advancements, such as software-defined networking and network virtualization, technologies that were originally developed and are now widely deployed in network data centers. When combined with fiber's vast capacity and robust reliability, these technologies enable a different model, one far better able to achieve and exceed the goals set by the Telecom Act when the age of digital connectivity was just beginning. We outline the key features of that model in the rest of this presentation. We start by giving the model a name that highlights its purpose: Community Empowerment Networks. We also give it an acronym-based nickname, Digital Commons, which emphasizes the open and shared nature of these networks. A helpful way to understand this model is to consider its parallels to the local road networks that transport people and physical goods and services throughout our communities. For example, they both expand opportunities to connect, compete, collaborate, innovate, and create value. Both have rules and mechanisms that support safety and equity. For example, to enhance safety, cars pull over for ambulances and stop for school buses. And our safety-focused speed limits apply to all of us, no matter how expensive our car. Both operate as nonprofit enterprises. Costs in both cases are shared across different types of users and stakeholders with an eye toward equity and sustainability. Community empowerment networks add to this several important benefits. Compared to physical roads, they are much cheaper to build, maintain, and add capacity. They are more climate and environmentally friendly. They employ advanced technology that was first developed and is now widely used in data centers, known as software-defined networking and network virtualization. These technologies allow networks to add new lanes of traffic in the form of new services, new providers, and new capacity, quickly and inexpensively. This contrasts sharply with physical roads, where expansion tends to be very slow, very expensive, and often very disruptive. An important feature of digital commons is that it allows ISPs to enter, innovate, and compete in local markets without having to build their own network. To put this in perspective, consider what it would be like if UPS and FedEx, and maybe also Amazon, Ford, Walmart, and other companies, each built their own road network all the way to every home and business. That would be a huge waste of time and money. Though it costs a lot less to deploy fiber than to build a paved road, the principle is the same. As with physical roads, the most cost-effective way to support efficient markets and public services in the digital world is to deploy a single high-performance network open to all service providers in a non-discriminatory and non-profit basis. And because a digital commons supports easy market entry, reduces ISP costs, and encourages healthy competition among them, it leads to lower prices for end users. In Ammon, Idaho, for example, the city's open access fiber network, which offers a choice of service from 4 different ISPs, saw a 90% reduction in the lowest available price for gigabit speed service in less than 3 years of operation. This doesn't represent the full cost of that service, but as we discuss in a later slide, that total cost is still well below the industry average and may very well be the nation's lowest price for this very high-speed tier of service. The network in Ammon reflects a healthy blend of conservative and progressive values and the respective strengths of the public and private sectors. This is reflected in the following comments by the city's mayor and the CEO of a private ISP offering service on the network. The comments are part of a 20-minute video about the Ammon network available on YouTube and produced by the Institute for Local Self-Reliance and Next Century Cities.
Is this appropriate for the public sector to enter in and potentially compete with the private sector, which of course is why we ended up with an open access network. That was really the motivation and drive, is so we could go to the public and say, we're not competing, we're actually enhancing competition.
I didn't think the city belonged in the fiber optic business. I'm one of those conservative people that believe government should be small. Having said that, I do know what the city is doing, and having watched what they've been doing after talking to them, working with them, and actually participating on the service, I'm happy with what they're doing.
The economics of the Ammon network, summarized in this table, reflect the success of this alignment of public and private sector strengths. When the network was being planned, the incumbent ISP was delivering 30 megabytes downstream and 5 megabytes upstream, with a maximum monthly data cap above which customers were charged extra usage fees. According to a survey conducted by the city at that time, this ISP's average customer was paying $93 a month, including extra fees triggered by the data cap. As the table shows, the total monthly cost for customers switching to the city's fiber network dropped nearly in half to less than $48, while the speed they received increased dramatically to 1,000 megabytes or 1 gigabit per second in both directions. Several things helped make this happen. The first was the city's ability to finance the network through a long-term, low-interest bond, which reduced the monthly payment needed to finance the network's capital cost. This contrasts with the much faster payback required for most for-profit ISPs. The second major factor was the impact of competition, as illustrated in the earlier slide, showing the sharp decline in ISP pricing during the Ammon network's first 3 years of operation. Helping to make this aggressive price competition economically viable for ISPs was the network's use of technology that reduced the cost of market entry and operation for participating ISPs. It's also important to note that when the bond that financed construction is paid off, the network's customers will be paying a total of less than $27 per month for symmetrical gigabit service. So what else does a community empowerment network do? As its name suggests, a community empowerment network shifts the balance of power from ISPs to network users and what we refer to as community service providers, or CSPs. Instead of controlling the local network as gatekeeper, toll collector, and rule maker, often in communities where they operate as a local monopoly, ISPs must now compete to earn the opportunity to connect customers to the public internet on the state-of-the-art high-performance fiber network. At the same time, a variety of private and public sector community service providers will be better able to deliver value by leveraging this same high-performance network. For example, medical practices will be able to more quickly create and more effectively manage secure private networks for their patients and practitioners, with schools able to do the same for their teachers and students. And governments, utilities, local business, and public safety organizations can use the network to improve the efficiency and security of their internal operations and their public-facing services. Community empowerment networks increase choice, ease of use, innovation, and efficiency. With only a few mouse clicks, network users can compare the prices and services of competing ISPs and sign up for, cancel, or change their service provider. They can also become community service providers using the network to provide fast, secure, reliable connections that empower their employees, customers, patients, students, and communities to better address their needs, interests, and goals. The following video provides a demonstration of this functionality. It is based on the automated provisioning and network virtualization technology developed by Entry Point Networks, which is used to serve customers in the Ammon, Idaho network discussed earlier in this presentation. In this video, we will demonstrate a network customer subscribing to an ISP service, then canceling that service and subscribing to a different ISP. We will then demonstrate the same customer self-provisioning a special circuit or private network over the same fiber strand. The first time a new customer accesses the network, they are taken to the subscriber portal where they can subscribe to available services. The customer selects internet service from the menu and is given a list of all providers and offerings. They choose a plan and click subscribe. They are taken through the specific terms of the ISP subscription. Once accepted, the ISP network is automatically provisioned. A few seconds later, their dashboard shows an active ISP subscription. They now have internet connectivity and can search the web. If for any reason the customer decides to switch their ISP, a couple mouse clicks and 5 seconds later, they are no longer subscribed to that ISP service. They can then repeat the subscribing process by selecting a different ISP option after accepting the service terms. The new ISP network is automatically provisioned, and a few seconds later, they are subscribed to a different ISP service as shown in their dashboard. Setting up an off-internet private network connection or special circuit is just as easy. The customer selects private LAN from the menu. They click through the network subscribing process, and a couple mouse clicks later, the network is provisioned. They are automatically routed to the network portal where they identify as network host, entering their unique IP address and selecting the host button. Once the network is configured, they are given a private network code to share with those they invite to join their private network. Returning to the subscriber portal, the customer's dashboard now shows 2 services running over their single fiber network connection. By enabling community service providers to generate increased revenue, operational cost savings, and improved outcomes, a local digital commons encourages creative and win-win network cost sharing. For example, if a community's healthcare providers see enough value in having their patients connected to the network, they might be willing to contribute to its capital and/or operating costs. The same might be true for a community's school districts, large businesses, and public utilities. The need is great, but so is the opportunity. Consider empowering your community with a digital commons.